I'm Chris Rutter. I'm a security tech lead with Eco Experts. I started my career as a software developer who gradually moved into security. I've spent the better part of 3 or 4 years helping to kind of shoehorn security practices into kind of modern, agile, cloud-based transformations. Where security goes from every 12 months to every commit, basically. And most of my talks are based on kind of loosely disguised battle stories that I've had, where hopefully you'll come out with some practical advice that can help you in your day-to-day jobs. So I've decided to try a different technique for this talk. So I'm basically just going to start with a conversation. I think all of you engineers and security guys will have been part of this conversation at one point on both the good and the bad side. So I think some of it will resonate, and then we'll kind of dissect what's went wrong and look at some techniques to try and make it a bit better. So if we set the scene, so we've got a 1-year-old AWS-based DevOps project. They've managed to finally get to weekly releases to prod. It's something shiny that's like blockchain, fintech, something that's really cool, making tons of money. They've got 50 microservices on ECS in AWS. They've got 5 cross-functional teams of 8 people. So you've got 5 teams. You've got a mixture of infra engineers, developers, testers, product owners, business analysts. No security though, as of yet. They've got the attitude of you build it, you own it. So each team builds their own infrastructure, manages their own permissions, manages their own databases. Each team has on-call engineers. It's a pretty common setup these days. They're currently running Terraform to provision their infrastructure, and they're running all of that from a Jenkins box. But the devs are still troubleshooting from their laptops, and the engineers, the infra engineers, are doing the same. So our part in this discussion is that we're part of a newly formed embedded security team. So we've joined a year after the guys started writing code, and we're currently reviewing all of the systems. So most of my talks in the past have been you're kind of part of that initial sort of yay, let's develop something, and it's really cool because everyone's passionate and there's loads of money flying around, and it's really easy to kind of change processes because everyone wants delivery. This is the kind of dark side of it where it's kind of already been delivered, no one's been hacked yet, and you've turned up and there's some serious problems, and you need to think, well, how do I actually kind of manage this? How do I make these things get better? So you've been there about 3 weeks, and you start reviewing the IAM policies. Hands up if you're familiar with AWS. Okay, or Azure. I'm guessing that these policies would look something like each other. Now this is a contrived example, but I've seen things in the wild that aren't too much better than this, to be honest. So we've got the infrastructural engineers. You've got 1 or 2 in each team, and this is the policy that you find that they've been using for the last year. It's been rapid, man. They've been able to develop whatever they want, whenever they want. They can troubleshoot a problem run on the toilet at 4 in the morning. It's fantastic. But there's a lot of stuff there that could, in a security mindset, that could do some serious sort of damage. So EC2 allows you to, provision any instances that you want, allows you to change networks, build almost the whole of the deployment, to be honest. IAM basically allows you to create whatever you want in terms of a role, so you can elevate your privileges to whatever you fancy. RDS allows you to, dump databases or delete the whole database if you like. Quite a lot of stuff there. And the resource star, so no granular access controls, just, you're allowed to access anything you want. Sorry? Is that CP? SCP? Yeah.
No, is it account-wide or just role-wide?
So let's say this is a particular role. So let's say that this is a role that 10 of your employees are using, the ones who are infra engineers. So let's say this is the software engineers policy. Very similar, very open, very wide. It's a little bit lower down in the stack. It's looking at getting secrets, managing DynamoDB, which is a document database, and queues and all that kind of thing. But they still have IAM permissions. They can still basically create any policy or any role that allows them to do whatever they want. Now again, this is a little bit contrived, but I've seen things that aren't too far, and I'm sure some of you... Well, exactly. But a lot of people don't know that, or what they do is they think that they'll deny the ability to modify your own role, but they won't deny the ability to create any other role. Is this just me? Hands up, anyone who's seen any of these kind of policies? Good. All right, the talk's going to go well. Okay, so this is the kind of discussion part. So This is a familiar conversation. I think before security started getting closer to development teams, this is the kind of conversation you would have with a security person who is very, very much outside of the development lifecycle, is acting almost as a project manager, and they're just kind of managing pen test findings or compliance reports from external entities. This is the kind of conversation you might have if they found something like what we've just seen. Okay, security team. We need to perform an access control review across all 5 teams and immediately restrict these permissions. Sounds pretty sensible. Engineers. Hold on a minute, you don't even trust your own engineers? What if I'm a call at 4 a.m. and the queue's full up? What happens then? Now notice that the engineer, the first thing they think of is the worst that could possibly happen. But not in terms of security, it's in terms of what goes wrong if the queues get full and I can't flush them in time and the system goes down. So engineers can think negatively too. Product owner. Yeah, that sounds like a lot of work. We've got a big deadline in 3 months and we can't really afford the disruption. Security team. But we've classified this as a high risk. Your teams are violating the principle of least privilege. I mean, come on, you can't do that. Product owner says, risk acceptance, you say. Go on then, I'll send you an email. Thanks, I'm not missing my deliverable for this least privilege crap. The pen test said we're golden, so I'm covered. Lol. Okay, so hands up if anyone's been through any part of any of that kind of conversation as an engineer or a security person. Yeah, we've all been there, we've been on both sides of it. Okay, so how can we kind of stop this thing happening? To me, avoiding that situation is the core of what DevSecOps is about. Everything that went wrong there was because of a lack of understanding, either a lack of understanding of security principles from the engineers or the product owners, a lack of understanding about deadlines or the pressures of delivery from the security people, and a lack of translating the stuff that they learn in a CISSP book or an information security course, translating that into something that developers kind of care about and can touch and feel. There was none of that going on in that conversation. So let's try again. Okay, so instead of saying this, what we do is we sit down beforehand, before we kind of, crap ourselves and say, right, we need to do a review straight away. Figure out what is it we're actually scared of. Let's not just throw away this term of privilege, principle of least privilege. So what we're really scared of is a developer's credentials being compromised, or an engineer's credentials being compromised. It's probably the easiest way for an attacker to pawn your whole system, is if they can just grab credentials from someone's machine and they've got the keys to the city. It's all in the cloud, happy hunting. We're also scared if one of our system components is compromised, be it a container or an EC2 instance, and it has some kind of credentials or permissions on there that allow kind of horizontal or vertical escalation across the system. We're really scared about that. We're also scared of insider or ex-employee attacks. Now that's instantly what developers think we're all about. They think we don't trust you, we want to limit your permissions and take away your suites. We don't care that you've got stuff to build, we don't trust you. To me, it's probably the highest impact if it happens, but it's way down on the list. And in my experience, if you protect against the top two, if you protect against credentials compromise, then you've gone a long way to protecting against an insider threat as well. What are the capabilities that we really need? We need to detect if these things happen, if the credentials are misused, however they've been exfiltrated. And we need to be able to revoke access to these things quickly, ideally without stopping the whole kind of development pipelines. So these are what I call kind of concrete risks. These aren't just kind of terms we're banning about. These are concrete things that you can say, we don't want this to happen, specifically to us. So then what we do is whatever forum your developers use to spread ideas or try to convince people of new sets of work that they want to commission, we find whatever that forum is, whether it's a brown bag at lunchtime or whether it's a tech talk or a screencast or whatever, depending if you're co-located or not. And we do a tech talk and we say, look guys, this is pretty serious stuff. So we tell them that most people who use Terraform, basically if you're using MFA, which you should be, every single time you run a command, you would have to type in the MFA code. So what happens a lot of the time is that the people use a different tool like AWS Profile or AWS Vault, which basically have an MFA authenticated session and store it somewhere in the file system. So they cache the STS token. It's pre-MFA authenticated, it lasts 1 hour. It basically allows you to do whatever your permissions say you can do. So we show the developers, look, if you look on your machine at this file, I guarantee you're going to find some credentials there that don't need MFA. And if anyone gets hold of them, then they're basically going to be able to do whatever you can do. Now in security, that kind of scares us because we know that everyone's using this one big role, and we know that everyone's using it 8 hours a day. So the attack surface of that is huge. There's 50 people with pre-MFA credentials on their laptops all day. So that's kind of scary for us. We then show them how easy it is for somebody to get hold of these credentials. So this is kind of half pseudocode Python. So all you have to do with Python or Java or Ruby or anything where you download dependencies, which I think is like 98% of most code bases these days, or 99 since I was a developer. It just takes 3 lines of Python to open the file system, grab those credentials, and send them off somewhere on the internet. It's very easy on a laptop because you're probably not behind a proxy. Maybe you're working from home. Even if you are, all you have to do is base64 the data and send it as a subdomain in a DNS query, and it pings off through a DNS tunnel. A lot of people don't have their own bind servers, so even if you're using a company proxy, it's probably going to get out that way. So it's very, very easy for someone to get your credentials. You're showing developers this. This could be on your local machine, it could be on a Jenkins server. It doesn't have to just try and read the file system. It could basically run any command at once. Your laptop's completely pwned. It's a lot easier than you think to get hacked with this kind of stuff. This happened just a couple of weeks ago. We had to investigate this in my current position. There was a Ruby library to do with a REST client. The last 4 versions for like 3 weeks it had some malicious code injected into it. We found out on a few of our machines. Everyone panicked. Turns out it was okay. But there's a lot of people using this stuff. All it takes, do you really, when you looked into how this happened, the guy hadn't changed his password in 10 years. It was found on a pwned site from some other breach. And they just went through all the common libraries in Ruby, found out what his username was, looked on haveibeenpwned.com and tried his password, and they got access to the repo. Instantly, thousands of people around the world download this code. Your credentials are with the hackers. It does happen. So also, a lot of developers, you show them kind of how good phishing is these days. They say, I would never fall for phishing. I've seen this. They do fall for phishing. They definitely do. I hope I haven't fallen for it myself. But when you realize, this is not phishing where it's, your long lost uncle from Nigeria who's sending you $50,000. They'll scope out your LinkedIn profile of your organization. They'll find out who your boss is. Maybe they've already exploited something else and they've got access to your Slack system or your Teams or whatever. I showed our developers, I got hold of some Slack credentials and I masqueraded as one of the guys in charge of the platform I work on. And I sent a link to the big group Slack channel, which said click on me, and it opened up David Hasselhoff saying you've been pwned. But if that was a realistic looking Amazon login, I guarantee you at least 50% of people would have clicked on it from that person. So okay, we've done a tech talk. We've convinced everybody that, look, this is actually kind of realistic stuff. I'm not just throwing out a principle to you. I'm showing you that things that we use and the way that we've set these things up can very easily be subverted, and it's bad news. And then you show the developers their permissions again, and their mindset has changed now. So they're not just thinking about, yeah, well, I need that to get my work done. They're sitting there thinking, well, what if somebody got hold of these credentials? What could they do? And then it gets pretty scary. I mean, if anyone is familiar, can anyone volunteer to tell us some scary things that you could do if you got hold of some of these credentials? Anything you want, yeah? Yeah. And I mean, even if this is contrived, right, even if it was like a subset of this and there was still some way to spin up an instance and open up some security groups, you've got shell access to the whole network. It's very hard to lock these things down properly, but making sure developers have in their mind the kind of risks if they don't is very key to getting them on side. When you kind of take away their sweets, it's kind of how they see it. Then you show them, okay, so we know that everyone's using the same role. You say, okay, how do you think we would detect if this has happened? So we've showed you that it's quite likely that somebody could get your credentials. There's 50 machines, and all you have to download is a dodgy dependency on from Maven or something like that, and someone's got your creds. I'm going to show you how we track this stuff at the moment. I'm going to show you how CloudTrail logs look like. I'm going to show you how whatever SIEM solution we have. It basically just shows that there's 1,000 commands a day from the same role. There's no context whatsoever in any of these messages. And if we try to somehow build an idea of what's going on, just from these kind of events, it's going to be brittle, it's going to be out of date. For it to be of any use, it's going to block you. There's no way to understand what's going on if everybody's using the same role and no one knows who's supposed to be doing what. Okay, so what are the results of, some people say that's like fear, uncertainty, and doubt. I don't think it is. I think it's just showing an engineer that, this really could happen to you, specifically based on how we work. It's not just saying that, you could be ransomwared and it's really scary. It's saying you could be ransomwared because someone could easily phish your credentials and within 10 minutes, they've got access to all of your machines. So the results of doing this kind of exercise is that we as a security team have a set of understood and concrete risks. We know that we're scared of sensitive sessions sitting on machines. We know that there's a high likelihood of credentials being compromised. We've highlighted what the credentials can do, and the developers have that in their minds. And we know that we don't really have the capability to detect any misuse of this stuff. Another great benefit is that if you show people how scary that is, I've used this technique many times, and not once will you get a developer or a product owner come up to you and say, don't care about that. It's very compelling. It kind of, it does show people that it's important, and you would get completely pwned if it happened to you. The way we did that is we delivered, rather than just saying you're violating the principle of least privilege, we demoed this stuff. We demoed it using code. We demoed it using technical language. We treated it just like any other non-functional requirement. If you've ever seen developers now in an agile environment, a lot of decisions are made on using this kind of demo. You get your senior developers together, somebody proposes, let's change to gRPC, and then everyone presents the case and they go, yep, okay, enough people have agreed, let's do that. That's how decisions are made these days in technology. It's not the old way where you'd battle the project managers to get my piece in. So we have to act and understand that that's how decisions are made, and kind of present our case in the same medium. It also makes it very difficult for a product owner to accept the risk when it's being so clearly illustrated to them what the exact consequences of not acting upon this are. Right, I've talked for a bit there, so I usually try and have questions kind of as I go through the talk. Any questions on this first part?
Everybody can relate to Chris's scenario?
Yeah.
Mm-hmm. Have many of you guys tried this kind of technique where you do a sort of tech talk and try and sort of build awareness within development teams, or being part of one of those talks? Okay.
I find that most people don't listen. So if I talk to some stakeholders, product owners, their point of view is just it's not serious enough. We don't understand the problem. We don't care about it. Works for us. Having weak passwords, everybody's fine. Sharing passwords with everyone, even having supervising roles, it's more than fine. Everyone's doing their work. Nobody updates accounts, passwords. Nobody's able to accounts. Stuff stays there, and nobody seems to care.
So not quite in the same vein, slightly different. But I used to do office sweeps and pick up all the laptops and left on desktops, and then plug them. And then people would come into the office and find their laptop gone, and then ring us to find out what happened to the laptop. And so the full demonstration, I definitely see those two.
Yeah, really. We had not quite as cool as that, but recently, we had quite a battle to introduce branch protection on GitHub repos. I know I kind of assumed that was modern development practice and how it worked, but there was an environment where that wasn't happening. So I just basically went to the main Terraform repository and I just checked in some code. I checked in some code masquerading as somebody else, and just watched it fly and watched it go to production. It was just a comment, and then I kind of showed everybody, and they kind of sit back and they listen, they say, oh, this could actually happen to us, and it was very easy.
So I have a very simple question to emphasize the irony of this problem. This example is coming from a highly regulated, possibly enterprise-run company, right?
So this is a very contrived example, but it's kind of semi-autobiographical. But most I'll kind of explain in the next section why these things happen, but most enterprises I've worked in have things like this, whether it's defined in the IAM profile or whether somebody's built a private Jenkins box on their own laptop that's connected to the company network. You know, it's there and they have those permissions, whether it's as obvious as this or not.
Well, just to put it in, so I've never used Amazon, but we use Google. When we started using Google, there was 3 permissions. You could be an editor, an owner, or a reviewer. That was it. Come now, and those were the only permissions we had to deal with. And now, like 5, 10 years down the road, there's a whole IAM structure.
Yeah.
But those initial permissions are still hanging around.
Exactly. Okay, so if we've the first section is that we found a way to express the sort of risk of what we found and express it in a way that we think developers and product owners can't ignore. The next sort of bit that we'll tackle is, oh, well, that sounds like a lot of work. We've got a big deadline to hit in 3 months and we can't afford this disruption. They're kind of saying, well, we haven't been hacked yet. The pen test said it was okay, so why should I? There's nothing forcing me to deal with this. Although I kind of see what you mean now. You know, I'm not going to push the product delivery back by 2 weeks. Sorry. So what we do in security is if you have a team that's close enough to development practices and a security team who has technical expertise and an understanding of how development teams work, what they can do is they can, okay, well, let's research why. Let's overcome that objection. Let's see, why would this push the project back 2 weeks? Why would it take a month to make all of these changes? So we researched the current process, and then we realized that it's a hugely manual, time-consuming process to change any of these roles. That's the main reason why nobody's made them more granular, because as soon as a dev team wanted to build something, it was going to take them 2 weeks to request the permissions the first time, and these things take calibration. You know, you can't get it right every time, so you want to try and trim down to what you need. They realized it was impossible, so every time they just asked for the maximum permissions, and the person who granted them didn't really know what they were doing. The ironic thing is, in a lot of situations, this is because of a security requirement. This is because of an audit function or a checkbox security requirement that says you have to have separation of duties. And what happens is the person who's separating the duty, the person who's signing off the IAM changes, is generally somebody who doesn't really understand what they're signing off on. And it's somebody who's protected by emails and JIRA tickets, and they might be in a different, location to you. So what ends up happening is you either ask for maximum permissions, or the engineers just circumvent the current controls, and they find a sneaky way to give themselves super admin because they need it to do their jobs. So in this story, we find out that it takes 2 weeks, emails, tickets. It takes a lot to change these things. So we can't really say to the product owner, well, you can do it in a few days, because we know for a fact it's going to take 2 months. So with us being a security engineering team, we don't have to just sit there and tell people what to do. We can try and do it ourselves, feel their pain, and try and build something to help them. So what we do is we stand up our own AWS environment, or if we already have one, we start testing IAM role changes. We figure out it really is time-consuming and practical. They haven't just fobbed us off. This stuff really does take 2 weeks. It's not fit for purpose. We can't split this into deliverables. It's never going to happen if this stays as it is. So what we do is, with a security team, we can kind of fight the good fight. We can fight against the audit tick boxes, and we can fight against the old process. We say, okay, let's build you a new process. Let's base it on pull requests. 2 people have to approve it, and one of them has to be in the security team. We'll automate anything that's pushed into that and approved. It'll automatically be provisioned. We'll look at using permissions boundaries, which, if you're not familiar with them, are kind of like really clever whitelists, which you can set above policies, which stop people elevating their own permissions. And we'll sell this all to whoever's the person telling us that we have to do it with this 2-week process. We sell it to them, and we use terms like separation of duties and principle of least privilege, and we fight that fight on behalf of the dev teams. And we build this process. It shouldn't take long. We basically get the process now where somebody could change their own IAM role, self-service. It just needs to have a tick from somebody in their security team, and it's in production straight away. So the results here are that we get the ability to practically improve security. We have a process that's already been tested by the team, that we're not scared to kind of throw on unsuspecting developers that might take them too long or not be fit for purpose. We've used developer-friendly workflows. We're using Git, we're using automated provisioning. We're not using kind of tools that the developers never see. And this is actually likely to be used going forwards. We've made it so easy that it's easier to use our process than it is to circumvent our process. And that's really key. And we've been enablers. We've understood blockers, and we've helped overcome the blockers, and we've improved processes. So the security team have actually made your life easier. It's a fantastic double win. You're securing stuff and making people's lives easier too. Okay, quick question break. That's the second section. I think I've got one more after this. Any comments or questions on that part?
So in the case of the scenario you gave, I think you were talking about maybe someone like an embedded security being one of the people that does the approval. Sometimes that can lead to collision, whereby teams, if they know each other very well, they can agree to do things which are wrong. And that's the purpose of security, whereby we have a global means to segregate the duty so that people can check on what action they are taking as well. I think sometimes it's difficult, it's dicey to use that approach from my own thoughts.
Yeah, I understand what you mean. I mean, to me, if you have GitHub like pull requests, the separation of duties, there's two main benefits for me. One of them is that, if it would take two people to collude for a malicious change to happen, which drastically reduces the likelihood of anything, getting into production if two people have to collude on it. The main benefit, though, is it's basically just about making the approver somebody who knows what the hell they're doing. Now, a lot of the times, the person who's asked to approve this stuff doesn't really know what they're doing. It's just that they're a manager, or they're a product owner, or they're somebody who's a permanent employee amongst contractors. So if you can find the person who really knows what they're doing, whether it's the dev leads or whether it's the architects, it doesn't matter if it's a security team, it's just somebody who knows what these changes mean. That's the key. Make them the approver. Make it a quorum of approvers. It doesn't matter. You're right, you don't want security to be the bottleneck then, but if you've walked into an environment and no one's fixed this stuff, maybe you are the only person who knows how it works at that point. Maybe you have to train other people up to understand the permissions to be able to be approvers. Okay, so the last section. So risk acceptance, you say, okay, I'll email it to you. Thinks, I'm not missing my deliverable for this. The pen test said we're golden, so I'm covered, lol. So basically, there's no responsibility here for the product owner. They know that it's just one email. They'll probably be gone in a year's time anyway. And once that email's sent, it's just sitting on someone's machine. No one's checking this out in 6 months' time. No one's going to come back and tell them that they have to fix this stuff. This happens a lot. Sometimes it's a spreadsheet on someone's laptop. Sometimes it's a GRC tool that no one's allowed to access. Sometimes it's just an email saying, I accept the risk. And they know that if the shit hit the fan, they'll just say, well, it wasn't explained properly to me. I didn't understand the risk. Nobody told me what principle of least privilege meant. So what we do is all the kind of analysis and reporting that we did early on when we did the demo, we need to put that into a report that's very difficult to ignore. So this should be lightweight, 1 or 2 pages, but it's concrete, specific to our environment. It should be shareable, so it's not just living on one person's machine. And it should be in the format that it can be passed up as high throughout the chain as it needs to be. I've used this technique before. If product owners don't care, you escalate another level. If they don't care, you escalate another level. It gets right to the top, and you find somebody who reads this document and goes, well, I can't have that. And suddenly the doors are opened, and suddenly the project starts happening. This stuff has to be documented. The concrete risk to your estate has to be there and unavoidable. Once you have this, it makes it a lot more difficult for a product owner to plead ignorance. You can prove that they've read this document. You've got the audit trail on Google Drive or whatever platform you're using. They know that they're culpable now. I mean, that sounds a bit kind of too far, a bit sort of adversarial, but they can't ignore it basically. You've got a lot of kind of audit there. So then what we do is we create a set of templated user stories to help product owners plan the work that we've suggested. Because we've already improved the processes and made this something that can happen, within a couple of hours or a couple of days, an IAM change, then we can suggest, okay, you do the access control review. We'll tell you it'll take 2 hours of 2 engineers' time. You identify your sensitive resources, your sensitive buckets, your sensitive roles, the secrets that you want kept, and then you tell us which roles do you think should be able to access those things. And we recommend you just have a read-only role that the engineers use most of the time. Then we'll say, okay, what are your most risky resources that you really care about? Okay, let's create user stories based on granularizing those things first. You can do them, you don't have to delete your old roles, you can test them in production, and then you can make the switch. Then we'll say, okay, the last stage of this rollout is to remove the old roles completely, once everyone's stopped using them. And then we can say, right, let's go on to enabling alerting. Let's build something that allows us to alert on when these things are being misused. So suddenly you go to a product owner now, and you say, well, I've got 12 or 13 different stories here. Surely you can pick up 1 or 2 of them next week. Surely you can pick up 3. Surely you can pick up the 5 most high-risk items before Christmas and do the rest of it after your deadline. Surely that's going to make us a security benefit and give us a kind of iterative improvement on what we've had. You do this for every team. So every team, you put these stories on the backlog, or you ask the product owner to put the stories on the backlog. If you're using Jira, Jira is a great tool for tracking these things. So these risks or these potential mitigations aren't just lying on a spreadsheet on someone's machine anymore. These things are Jira tickets which are timed, which can be tracked, which have a very powerful query language. So we add some labels on them to say that they're mitigations. And with Jira, we can now make very complex reports, depending on how many labels we want to add, to figure out, so who's been mitigating these things, who hasn't, who said they would and they didn't do it, who hasn't touched the story in 3 months. All of that's available through JQL queries. So the idea of making these risks kind of alive and making something happen to them now is a lot more easier than when it's sitting on some bloke's laptop in a spreadsheet. The result of this is that we have a much better risk acceptance process. It becomes very difficult to accept the whole risk as one chunk. You've got 12 user stories now of varying different levels of risk and varying different levels of implementation effort. Nobody's going to say, well, I'll just accept it all, especially not with the report that you've linked to all the stories. It allows you to negotiate, do 4 of them now and do 6 of them later. And it allows you to track those things easily using Jira or whatever ticket system you use. It allows you to define these user stories very well. It allows the product owner to commission the work. It makes it easier for engineers to pick up. It's a lot more granular. You've done it yourself. You understand how to write these stories. You understand the pain the developer's going to go through. And like you said, you can focus on the high-risk items as well. So what does the conversation look like now? Okay, here's a tech talk on how risky our current access controls are. Engineers, wow, that's pretty scary. We should really fix that. Product owner, that does look scary. I'll commit to fixing it, but we have a big deadline soon. So can we do it after Christmas? Also, why didn't the pen testers find this? See, that kind of pen tester attitude has changed now. Now they're asking, why aren't they good enough? Whereas before they were saying, well, what are you talking about? They said it was fine. Security team, well, we've actually been busy. We've improved the process. So we can give you these stories that we estimate would take 3 days, and you can just do the first 4 of them. And we're happy for you to accept the risk for the rest of them until after Christmas. I'll go on then. I'll put the stories into next week's planning. So the conclusion of all of this. So based on the techniques I've been through to change that conversation and to change the outcome, security teams should just treat themselves as just another technical team who manage any other non-functional requirement. We should forget the whole we're important, we wear suits, we come in and tell you what to do. Security is just like performance, so it's just like accessibility, or it's just like the maintenance of your test suites. You have to kind of convince people that this thing's valuable. You can't just say it's security, it's important, so do it. You have to understand the pain developers go through. You have to understand how they work. You have to try it yourself. You have to set up your own environment and kind of understand before you go and be prescriptive and say you have to do this. You have to be pragmatic and settle for iterative improvements. Sometimes you have to put yourself on the line a bit as a security person to say, I'll accept 4 out of 10. And that's me saying that's a good improvement. It's a lot easier just to stand back and say, well, I wanted you to do all 10 and you didn't do any of them, that's your fault. So sometimes you have to take responsibility of that and say, well, yep, I think that reduces the risk to a sufficient amount. And you have to make sure that responsibility is allocated. Most of the bad security I've ever seen is not because people don't care about it, it's because it just fell through the cracks and nobody owned it and nobody was being made to think about it on a regular basis. So that's it. Any more questions? Yeah.
and then an excuse for that.
I think that depends on your environment. You know, if you're working in banking, there's a lot more kind of clout and, you know, regulatory stuff you can throw at a team to make these things happen. And you can work inside a space where you say to them, look, I'm making your lives easier here. I'm enabling you to release. You know, I can let the bricks fall on you if you want, but I'm trying not to make that happen. And you've got that kind of stick to hit them with. In other environments, like a startup who hasn't even had to do an audit yet, it's a lot more difficult. And sometimes you can't. Sometimes you just have to make sure that it's always on someone's radar, and you're always kind of pushing to keep that process alive, that somebody has to admit responsibility for this. That's two kind of extremes, but I think your job in security is to make sure it's always on the radar, make sure it's always being looked at and it doesn't fall through the cracks.